All right, guys, welcome back. We are going to do some examples today to continue down this path uh, with working on our trig identities. So let's do some examples from the book. It says use basic identities in algebra to simplify the expression. Assume all denominators are non-zero. So first up, we have sine t plus cosine t times the sine t minus cosine t. We have to FOIL this like we would normally do any function in algebra. So sine t times sine t gives us sine squared t. The outside would be negative cosine t times sine t. The inside would be cosine t times sine t. Now, because it's cosine and sine, I'm going to write it the same way, simply so I know that these are like terms. Like I could have wrote this one sine t times negative cosine t, but I want it to look exactly the same. So I'm going to keep it cosine t and sine t, just so I know that I could combine these two terms. Then we have on the outside minus cosine squared of t. Cosine times negative cosine gives us minus cosine squared. On the inside, I have negative cosine t sine t plus cosine t sine t. That tells me that I can cancel these out. It's just like negative 1 plus 1. They cancel. Then you have sine squared t minus cosine squared t. Now, you might be tempted to think that this is one of our Pythagorean identities, but our Pythagorean identity says plus in the middle. So we can't go any further with this one. It's our final answer. If we look at number 24, it's a little different. I have 1 minus tan squared t over 1 plus tan squared t plus 2 sine squared t. So the first thing I'm going to do is I'm going to look at my Pythagorean identities, or just at my identities in general. I'm going to look for 1 minus tan squared and 1 plus tan squared. When I look here, I see that I have tan squared plus 1 is equal to secant squared t. So I know I can change that denominator. I'll do 1 minus tan squared t on top still. And this just turns into secant squared t plus 2 sine squared t. This didn't really simplify it at all for me. So I can't do anything with this top here. I don't know what's going on with this bottom. So what I'm going to do now is I'm going to try to combine my terms on the top. Since I can't combine 1 minus tan squared t, I'm going to try to change that tan. Tangent is also the sine over the cosine. So tangent squared is sine squared t over cosine squared t. This is still all over the secant squared t plus 2 sine squared t. Oh, it's getting good now. Now, in order to combine my 1 and subtract the sine squared from it, I need to have a common denominator. So I have to multiply the top and bottom of this 1 by cosine squared t. That gives me cosine squared t over cosine squared t minus sine squared t over cosine squared t. And while I'm at it, I'm going to turn this secant into terms of sine and cosine too. So that's going to be 1 over the cosine squared t. And this is all plus 2 sine squared t still. Combine my top values, cosine squared minus sine squared now. that's all over cosine squared of t. That's all over 1 over cosine squared of t plus 2 sine squared t. Oh, it's getting good now. Flip the denominator and multiply this. So that gives me cosine squared of t minus sine squared t over cosine squared t times, I'm just flipping this denominator and multiplying, cosine squared t over 1. And this is still plus 2 sine squared t. My cosine squareds will cancel. I'm left with just cosine squared t minus sine squared t over 1. So cosine squared t minus sine squared t. Anything over 1, I can get rid of that 1 in the denominator. Just don't worry about it anymore. Plus 2 sine squared t. I'll have a minus sine squared t plus 2 cosine. So this is like a minus 1 plus 2. That gives me just 1 sine squared t left. So I'm subtracting this 1 from 2. So I have cosine squared t plus sine squared t. Now this is a Pythagorean identity. Cosine squared plus sine squared is equal to 1. That's my final answer. So I went all that way to come up with an answer of 1. These can be difficult. Make sure you're looking at your identities, trying to get everything to look kind of the same. Notice I went from tangent and sine and secant all down to sine and cosine. That's usually a fairly good method to get where we're going. In exercises 33 through 36, use the Pythagorean identities to find sine of t for the given value of cosine t. Make sure that the sign is correct for the given quadrant. So if I'm using the Pythagorean identities as it tells me to, let's look back at those. My Pythagorean identities are sine and cosine. So if I have cosine squared of t is equal to 0.5, negative 0.5, I apologize. Then I'm doing sine squared t I look at these instructions and it doesn't make sense to me what they're telling us to do. So we're going to do it my way. Much easier. If I know that the cosine of t is negative 0.5 and I pull up my unit circle, I guess I should do that. Pull up this unit circle. Where's my cosine negative 0.5? That's right. It's here at 2 pi over 3 and at 4 pi over 3. So those are the two spots where it's at. Now it also tells us that our quadrant that we're going to be in is between pi and 3 pi over 2. So again, if I look at my unit circle, this is pi and 3 pi over 2, so it's got to be in the third quadrant when the cosine is negative 1/2. So it's going to be 4 pi over 3, which tells us that our sine is negative root 3 over 2. No reason to do the Pythagorean identities there. Just use your unit circle and you'll find it perfectly fine. Number 37. Here we have sine of t equals 3/5 and t is between 0 and pi over 2. Use basic identities in the signs of the trig functions in each quadrant to find each value. So it starts with the sign of negative t. When we look at the sign of negative t, we know something about that. Go back to our identities again. The sign of negative angles means I take the negative sign of t. It tells us that the sign of t tells us that the sign of t is 3/5, so my answer would be negative 3/5. This is the negative sign of t, so this would change to a negative. We also have sine of t plus 10 pi. That's its own identity. And it goes into the, you know how I love this word, the periodicity identities, which is sine of t plus and minus 2 pi equals the sine of t. 10 pi is just a multiple of 2 pi, which means that we're multiplying it out 5 times. So we're going around the entire circle 5 times and ending up at the same spot. In other words, the sine of t plus 10t is going to be the same as the sine of t was. So it's going to be 3/5. I lost the problem. I don't know where it went. Okay, well, I guess we'll move on to verifying identities. Now, this is one of the harder topics, so we're not going to get into it very much. But basically, whenever you're verifying identities, what you always have to do is you have to work with one side of the equation. As we look at which side we're going to work with, it's important to know that you should always choose the more complicated side to work with. The reason for that is it allows you to simplify it. So if I start with negative cosine squared of x, if I'm looking at these two, I would say that this is the more complicated side. So I'm going to start with that side. Negative cosine squared of x, cosecant squared of x. So cosecant squared of x is nothing more than 1 over the sine squared of x. That tells us that we multiply the top, negative cosine squared of x times 1. So that's negative cosine squared of x over sine squared of x. Then cosine squared of x over sine squared of x. That's the cotangent. So I have the negative cotangent squared of x equals what's on the other side. Now again, I can't do anything with this side. Is there any way to simplify this any further? Not really. So what we have to do is we have to look back at our identities. And here we have the Pythagorean identities. So we have 1 plus the cotangent squared of t equals cosecant squared of t. That's not much help. The reason it's not going to help us so much is the fact that each of the Pythagorean identities can be expanded. Let me copy and paste those identities over to here so I can show you what I mean by expanded. Screenshot. When I look at these Pythagorean identities, each of these can be written three different ways. This is the first way, with the assumption that you can figure out that there's two other ways to write it. One would be to solve for sine squared of t. So get that by itself. That means it's going to be 1 minus the cosine squared of t. The other way would be to solve for cosine squared of t, which means I have 1 minus sine squared of t. If I look at this one, I can get the 1 by itself, which means I get 1 equals secant squared t minus tan squared t. Or I could get tangent by itself and do tan squared t equals secant squared t minus 1. Lastly, over here, I could have 1 equals cosecant squared t minus cotangent squared t. Or I could have cotangent squared t equals cosecant squared t minus 1. Sorry, I shouldn't have kept writing. So I know that this looks like one of these a little bit. So let's try to solve it. If I got my cosecant squared by itself, that would mean that I would, let's work on getting the cotangent squared by itself. Getting rid of the negative in front of here would mean I multiply by a -1 on both sides. So that would give me cotangent squared of x equals, then multiply everything over here by -1. -1 plus cosecant squared x now that's the same as cosecant squared x minus 1. Which is this. So it's a long way to get around. That's kind of the point I was trying to make. We're not going to get into these Pythagorean identities too much or verifying them, but I just wanted you to see what it looks like when you actually do it. Your whole goal is to kind of play with one side to get it to the point where we can figure something out. All right, that is it for today. I'll be giving you some problems like the ones we just went over. So good luck, and come on the Google Meet if you need help.